All right, let's walk through the process of doing these combined 10-2 and 10-3 problems for your last homework set. And I do want you to do these combined. I just want you to do one number 14 in your homework. So let's look at this. So in 10-2, there's instructions that say just test for linear correlation. And they want us to do the three things that we talked about in the last video. So they do want you to construct a scatter plot. They do want you to find the correlation coefficient. And they do want you to find the p-value. And again, we're not doing critical values, right? So no critical value. Just p-value. And determine if there's a linear correlation between the two variables. Okay. So let's take a look at 14. They've got some PSAT scores and SAT scores from college applicants. So this person took the PSAT, got a 183. They took the SAT, got a 2200. So is there evidence to conclude that there's a linear correlation between PSAT scores and SAT scores? So this is the time to grab StatDisk. It's good at doing all three of these things for us. So StatDisk. See, I already entered the numbers here, and we'd want to go to the correlation and regression. Show the sample editor. Okay. We want to do PSAT and SAT. So PSAT, SAT. 0.05 significance is what they wanted. Go and evaluate that. Step number one for us was actually the scatter plot. So again, you'll either take a screenshot of this or hit the little camera and you can download the image, or you can just carefully copy this down by hand into your handwritten homework. I do want these 8 points plotted somewhat carefully. You don't need to sketch this line in here. And you don't need to label your X and Y axes. So again, hopefully that doesn't take you very long to do that. Maybe a minute or less. So if we're doing number 14 here, part one would be just to make a little sketch. Let's see, 1, 2, 3. So 1, 2, 3. It's definitely easier when you can look at both at once. And then one kind of there, one about there. And then 3 up kind of over here. Okay, so I should be able to look at your sketch and get the basic idea of where the points are. That's good enough. 2 was to find the correlation coefficient, which is in StatDisk. Results. Correlation coefficient is 0.54329. That means the points fit a straight line, only about 54%, which doesn't seem great. Seems like maybe there's not correlation between these two things, or not a good enough correlation. But let's go ahead and run the hypothesis test to find out. Keep in mind the hypotheses are the same every single time here. The null is basically that there's no correlation, or the amount of correlation is 0. And if we reject the null and go with the alternative, then we say, yes, there is correlation. You don't have to write these down every time. I find it helpful to write it down a few times just so you remember. But really what we need is the p-value here. Say, are we rejecting the null? Go back to StatDisk. The p-value is 0.164. Right there, 0.164. That's not an unusual sample, so we're not rejecting the null. We're saying there's no evidence of correlation. And you can just shorten that to no correlation. So that would be done with the 10.2 version of this problem. And then we're not quite done because we are going to go on to the 10.3 version of this problem where they ask you to find a predicted score. So that'll always be the number 4 for us. So 4 says one subject not included had a PSAT score of 229. And the question then became, what kind of SAT score would you expect that person to have? We just got done saying there's no correlation between these two things. In other words, you can't use PSAT scores to predict SAT scores. If you look at StatDisk, you'll notice here it gave you that y equals and number. It gave you the equation of the line. So you have an equation. You could plug 229 into that equation. But steps 1, 2, and 3 all told us that's not going to be a good prediction. There's no meaningful relationship between PSAT scores and SAT scores. So if they want us to predict an SAT score for this student, we're not going to use the 229 at all. All we're going to do when we predict the SAT score is say, what's the average SAT score so far? So I just need to go back to StatDisk and say, I just want the average of the SAT scores. And again, so go under data, go under descriptive statistics, and say I'd like the SAT, descriptive statistics, and the mean SAT score so far has been 2152.5. So that's the best prediction you can make, is just to give the average of what's happened so far, because there's no relationship between PSAT and SAT. Okay, that's number 14. Let's run through number 16 as well, just to get it one more time. So 16 is asking if there's a correlation between altitude. Let's get on the right layer. Between altitude and air temperature. Outside air temperature. These are temperatures on an airplane. So it's when the airplane's at 3,000 feet, outside temperature is 57. When the airplane's at 14,000 feet, outside temperature is 24 degrees. So is there a relationship between those two things? So we want, back to StatDisk. Again, you would type the numbers in, altitude and temperature. I've done that already. So let's just go to analysis, go to correlation and regression. And this time we are doing altitude and temperature. Scatter plot looks really good this time. So again, this is number 1 here. The scatter plot looks basically like that. Yep, pretty much. The correlation coefficient is negative 0.997. So the correlation coefficient is almost 100%, which is not surprising, right? This is so close to being perfectly lined up. And it's negative because it's going downward rather than going upward, which would be positive correlation. We do need to go ahead and run the linear regression hypothesis test. Keep in mind that the null is no correlation. The alternative is yes correlation. So the p-value is 0. 0, 0, 0, 0. Right. which means we reject the null. And the null said no correlation, so that means yes. There is correlation, obviously. The graph supported that. The correlation coefficient supported that. The p-value proved that. Okay, so for part 4, I'll just move over here. For part 4, it said at a particular altitude, so an altitude of 6,327. We're interested in what the temperature is, or what we predict that it would be. And this time there is correlation, so we should be using that equation. So let's get back to StatDisk and copy that equation down. Let's see, the equation is y equals b0, which is 72.5. And then, so y equals b0 plus b1. b1 is negative 3.68. b1 times x. So negative 3.68 times x. Okay. There's the relationship between x, between temperature. Between altitude. Altitude is x. Altitude, and y was temperature. So we just need to put an altitude where x is, 6,327, and figure out our y. .68 times 6,327 was the value we needed to fill in. So that just says temperature at that altitude should be, and we just need a calculator. So we need 72.5 minus 3.68 times 6,327. That does not seem right. Why is that not right? Altitude. Oh, yeah. That does not seem right because I didn't read things carefully. So altitude here, they said altitudes are in thousands of feet. So in other words, this 3 means 3,000 feet. This 10 means 10,000 feet. This is 6,327 feet, but listing that in thousands means 6.327. So let's try that again. Let's do 72.5 minus 3.68 times 6.327. Okay, so now we're getting a more reasonable answer of about 49.2 degrees. 49.2 is the prediction from our equation. So that's the predicted temperature. So that was number 4. It's always nice when you make a mistake in like the very last video. Just leave a lasting impression with your students. It's good to know that your instructors are human too, right? So they do have a follow-up question, as they always do. How does the result compare with the actual recorded value at 48 degrees? So the thought they want you to go through there is to say, hey, this 49.2 just came from plugging into a model, a mathematical model. which mathematical models aren't always perfectly accurate. And they happen to know what the temperature actually was at 6,327 feet. It was actually 48 degrees. And the prediction's pretty good this time. Right? 49.2 is pretty close to 48. There may be a time or two where you find that the prediction isn't that close. Although really, if the predictions are going to get too far off, we should have said there's not correlation. But anyway, so that's it. Do the 10.2 and 10.3 problems together. So when you turn it in, I should just see a single number 16 with 1, 2, 3, 4 parts to it. And when you turn that in, you are done with stats homework. And you should give yourself a pat on the back, and you should go do something nice for yourself because you've earned it.